Hello, welcome to Advanced Algebra 2. Here we are talking about who knows, the sixth learning target. Having done the first, skipped the second, done the third, and pretended like the fourth and the fifth were important. And now all of a sudden, our equations have blown up on us. As the text says right above example 1, you are really going to live a fuller and almost, I want to say, a more meaningful life if you read the pages in the book on this, and it's on your notes. You're going to really understand why this is going on a little bit better. This is not the sort of thing I can describe on paper through the magic of the YouTube and the Google. So you really want to read the stuff in the book. There's some pretty awesome things going on about graphing in 3 dimensions. Here's a hint, it's a lie when you're doing it on paper, which is 2 dimensions, so you're trying to fool your eye. What the book does not adequately describe is how it can be incredibly frustrating if your eye is not made to see that, and that's an issue with people's brains and how they're made. It is not a problem, necessarily, except for the frustration. Alright, let's get to business. Now, here we have 3 planes that are crossed, and we're hoping to find the point where these 3 planes cross. This is going to be quite a bit of detailed work, and it might immediately look familiar, similar to what we did when we were writing the equation for a parabola when we had 3 points. It's actually quite similar, although here you have to do just a little more work at the beginning. So to get us started, I am going to number the equations 1, 2, and 3, just so I have something fixed to refer to here. And then when I do that, if you look at the first 2, they've got some x's, and if I go ahead and I multiply, for example, equation 1 by -2, that'll turn into -6x plus 4y minus 10z equals, what's going to be 38, I think. Nope, 34. Okay. And if I multiply equation 2 by 3, that'll turn that one into 6x. What do we got? We got 12y, and we're talking about -9z and 87. And the reason why I wanted to do the 2 and the 3 is so those x's line up opposite style. So now when I add the equations together, the x's go bye-bye, and I have 16y minus 19z equals 121. Okay. There, I combined the first and the second equations, and I'll call my answer for that equation 4. Now, I need to do it again. So much fun, I'll do it again. Here we got the first and the third equation. And to get rid of the x's, again, the trick is you want to make sure you're getting rid of the same variable as you did last time. So I'll multiply the first equation by -5. And there we go. And the second equation by 3. And here we have it. Remember, each of the coefficients and the constant multiplies. If I add that up, then the x's go bye-bye, and I have -8y equals -46z, minus 46z equals 106. Good times. I guess I'll call that equation 5. And now I need to combine 4 and 5 in a way that'll get rid of the y's. This one's not so bad, really. If you just take equation 4 and leave it like it is, and then I take equation 5, but multiply by 2. Now the y's will be all lined up and ready to leave us, hopefully nicely. Because, add it up, bye-bye y, I'm talking about -100, and 11z equals 333. If you divide both sides by -111, you get z equals -3. And you're like, yay! But the answer's like, well, maybe. So you've got a z, got to put that into some sort of equation with the z's in it, and in this case probably just y's. You don't want to go back to the original equations because they have x's and y's and z's. Z is not enough information. But if you put it into an equation with 2 variables, and you know one of the variables, you can solve for the other one. So here I've been substituting in -3, and I'm going to go ahead and subtract the 138. Divide by -8, and y equals 4. Alright, making progress. Now go ahead and throw that into your favorite equation with x's and y's and z's all together in a beautiful smorgasbord of awesome sauce. So the first equation was 3x minus 2y plus 5z is negative 17. So I put the y and the z values in now. And I'm making progress, feeling good about it. Combine all the numbers together, so the negative 8 and the negative 15, if you add them up, you end up with a positive 6 over on the other side. And you get x equals 2, so your point is 2, 4, negative 3. Boom, point. Now, this is a fair amount of work, no doubt about it, but it can be done. And it's almost exactly the same as what you did before. So I know you can do it. All right, this one looks simpler, but something should look a little strange to you. Each of them looks like it just has two variables, and that's true, except they're not the same two variables. So my first order of business would be to rewrite the whole thing, but leave blank spots where the missing variables go. So for example, in the first one, it's 2x minus 3y pause equals 5. And then for the next one, 4y plus 2z, there was a pause beforehand, equals negative 6. And then 5x, pause, plus 7z equals negative 15. And they're all lined up. Now, this can be easier than the first one because if you're super careful, like here, well, this isn't super careful. This is just labeling the equations. But now, if you're super careful, you're like, hey, why don't I just combine the first two to get rid of the y's? And if I do that, then I've got a thing with no y's. Okay, so follow along. The first one, if you multiply it by 4, you have 8x minus 12y, and the pause, and you got 20. And the second one, if you multiply it by 3, you have pause, and then you got 12y, and you got 6z, and negative 18. Now, if you add them up, then, pitchakoom, goodbye y's, you've got the 8x, you've got the 6z, and a 2. But no more y's. So now, this thing, which, it needs a name, and we could call it Bob, but instead we'll call it equation 4. This thing can go ahead and combine with equation 3 smartly to get rid of the x's. So let's see here. So equation 3 has 5x, and equation 4 has 8x. So if you take equation 3 and you multiply it by negative 8, then you're talking about negative 40x, and negative 56z equals 120. Take equation 4, and if you multiply it by 5, you're talking about 40x, and you're talking about 30z, and then you're talking about 10, and if you add them up, then the x's are gone, and you're talking about negative 26z equals 130. Oh man, we're rocking and we're rolling, because then z is just negative 5. Okay, now you take your z, and you're like, yay, but it's got to go back into some kind of equation with z's and one other variable. So maybe equation 3. There's no magic reason why it's equation 3 instead of equation 2 or whatever. Just, I don't know, equation 3 was closest. So you have 5x and 7z, but z is negative 5 now, equals negative 15. So 5x minus 35 equals negative 15. Add the 35 to both sides, 5x equals 20. Divide by 5, because really, and you get x equals 4. Okay, so you got z, you got x, still need y. Find your favorite equation with a y in it. At this point, you've already got z's and x's, so it just doesn't matter. I guess I used equation 1. The numbers were smallest. 2x, but x is 4, minus 3y is 5. So 8 minus 3y is 5. Subtract the 8, so negative 3y equals negative 3. Divide by negative 3, y is 1, and boom, you got 4, you got 1, you got negative 5. If you compare the amount of work here with the amount of work on example 1, this is a little bit less work. However, if you do not find this to be particularly compelling because you want to have a set system to do, you can get away with not noticing the missing variables and how it helps you. I do still recommend strongly that you go ahead and you that you rewrite it with the spaces and maybe even write in the zeros times the variable if you don't care for the method you see here. And then you can just do it like example 1. Again, very similar to how we did the equations for the parabolas. But if you do see it, you'll see there's a little bit less work. Okay, example 2 done. Example 3. All right, good. Whoa, this is gonna be fun. Okay, so we got equation 1, we got ourselves equation 2, we got ourselves equation 3. Nothing looks spectacular at the beginning. I'm gonna get rid of the x's with the first two, so I guess equation 1 gets multiplied by negative 13. That's gonna make the numbers kind of biggish and 13ish, but you know, 13's not that intimidating. It thinks it's unlucky, but no. Okay, so you got negative 13x minus 26y minus 39z equals negative 52. The second equation can be left alone now. So just 13x and minus 12y plus 19z equals 22. Go ahead and add them up, and boom, the x's are gone. That was kind of the goal. So negative 38y minus 20z equals negative 30. And, hey, you could be called Pietra or equation 4. So we'll call you equation 4. And then we need to get rid of the x's again. So in this case, maybe the first and the third equation. So, the first equation is x plus 2y plus 3z. It needs to be multiplied by negative 6. So negative 6x minus 12y minus 18z equals negative 24. The third equation, 6x minus 7y plus 8z equals 9. And ready to add them together to rock and roll and say goodbye to our x's. So we have negative 19y minus 10z equals negative 15. Yay, and you could call this one equation 5. Okay, two equations, got a y, got a z in each of them. Maybe get rid of the z's. Those numbers look nicer than the y coefficients. So maybe just go ahead and rewrite the fourth one. Negative 38y minus 20z equals negative 30. And then for the fifth one, maybe just multiply it by negative 2, so it becomes positive 20z. Add them up, and boom, by y's, by z's, by constants. We got nothing, folks. We got absolutely nothing except a smile on our face, because this is a situation with infinite solutions. We saw this before when it was just two variables and two equations. But here, same idea. If it all goes away, if 0 is 0, infinite solutions. Also, special bonus, less work. All right. I don't have an example of the no solution kind for you, but just like this infinite solution is very similar to the two variable example, the no solution is also extremely similar to the two variable example. This last one, we're not going to do all the way, but I want to just teach you to tame this, and you might very well notice it already. Some of you had similar ideas that you've talked to me about, and I'm sure some of you have had similar ideas and not talked to me about them. You look at this and you should either roll your eyes or scream because of the fractions. Either way, we want the fractions to be gone. And you can just take care of that by multiplying the second equation by 2. Gets rid of the denominators. Multiply the third equation by 3. They don't have to be the same number. Between the equations, it does not need to be the same number. So top equation doesn't need to change at all. Second equation can be 1x, could be 3y minus 5z equals negative 14. And the third equation can just be 5x. We got ourselves a 7y. We have negative 3z equals 3. And now we have a nice tame looking system of 3 equations. 1, 2, and 3. Now I'm not going to do the rest of it. It becomes really boring to see. It's very similar to example 1. So, it would go on, and certainly you should be able to do it. Don't feel like you necessarily need to. I believe I've just made up the numbers, so it may not even work out nicely. It'll work out, but it could be ugly. I just wanted you to see that, you can multiply an equation by a number, multiply a different equation by a different number to help yourself out with some variable problems. I'm sorry, some fraction problems. All right, that's it. Your assignment will be worksheet 1, so you'll get that in class next time. And thanks for watching. Please let me know if you have any questions.